Okay, chapter 8 is again on hypothesis testing, but now we have 2 samples. And we are going to concentrate on independent samples when the standard deviation is known. So the difference between independent and dependent. Independent has 2 groups that are not related. They may be different size groups, but you can't pair them up. You can't find correlation between the 2. Dependent would be like medical testing, a group before medication and after medication. Okay, you can actually pair those up, before findings and after findings. All right, so we're going to talk about independent today. Okay, independent today. All right, here we go. So classify each pair of samples as independent or dependent. Okay, so let's read the first one. Triglyceride levels of 70 patients were tested. Second sample, triglyceride levels of the same 70 patients after using a medication for 6 months. Dependent, right? Because they're same group. We could actually show Peggy's pre, Peggy's post kind of thing, right? Scores for 38 adult males on a psychological screening for ADHD. Scores of 50 adult females, psychological screening for ADHD. So even though the testing is the same, they're independent because they're 2 different groups. There's no way you can pair these up. I mean, they're 2 different sample sizes even, right? Easy enough. That's not real complicated. So we have a test on that alone. Okay. All right, so stating a hypothesis in a 2-sample hypothesis test. So the null hypothesis, again, has that equality statement. We are always going with the null as there's no difference between the 2 groups. The means are going to be equal. Okay? We always assume there's no difference between the population. So your null hypothesis is always going to be mean 1 is going to equal mean 2. That's always going to be your null for these 2 samples. The alternative could be greater than, less than, not equal to, okay? But we always assume, you always want to assume that there's no difference. So your null, your hypothesized mean, I should say, is going to be that they're equal. Okay? So you can have a null that has greater than or less than equal to deal, but you're always assuming that the means are equal. So here we go. These things have to be there in order to do this. The samples are from independent populations. The standard deviations of both populations are known. You know the standard deviations, population standard deviations. And then this is the formula. So it's very similar to the formula we did. This is the mean from the first sample minus the mean from the second, minus, remember the hypothesized, we said these are equal. So what is this always going to equal? What is U1 minus U2? It's going to be 0, right? Because we said these are equal. So in this formula, a lot of times you'll see that this isn't even there, because you're assuming that they're the same, which means that that would be 0. Okay, you're assuming there's no difference between. That's your hypothesis. Okay, so you're going to take the 2 means of your samples and subtract them, and then divide by the standard deviation squared over your sample size first sample, plus the second standard deviation squared over the second sample size. Right? Easy breezy. And we're going to do the same thing we did in chapter 7. We're going to state our claim mathematically. We're going to state our null hypothesis and our alternative. We're going to find our critical values with our significance levels. You're going to find the z-score. You're going to find either the p-value and compare it to your significance, or do the regions. Same deal. Okay. All right. All right, here we go. So here's your little guidelines. Identify the claim, state the null and the alternative hypothesis, specify the level of significance, sketch your sampling distribution, find your critical values, determine where your rejection regions are, find the standardized test statistics. So this is what we just did. This is that square root thing that was in the denominator. So that's another way of writing it. And then you're going to do your decision, reject or fail to reject, and interpret. So let's try a problem. Let's try one. Credit card watchdog group claims that there's a difference in the mean credit card debts of people in California and Florida. The results of the random survey of 250 people for each state is shown. The samples are independent. Assume that standard deviation for the first group of California is $960, and the second standard deviation is $845. Do the results support this group's claim? So, our null is there is no difference. Okay? The alternative is there's a difference. They aren't equal. So we're talking about a two-tailed test. So we've got our null, we have our alternate. What's the next thing on our list to do?
Okay.
Find your significance level. And they said they didn't give one. I skipped that. Huh? What do you guys want to use? I'm going to use the one that they tell me to use. Just so that we're all on the same page. All right, so our significance level, let's say it is 0.05. Okay. So if your significance level is 0.05, get your z-chart out. Give number 4. 0.05 is connected to 95%. So it's 1 point. And I think some of you guys were getting a little messed up on this and when do you split it in half. It is a two-tailed test. But the 5%, if you were to split it in half, you would be at 2.5%, low or high. So if you go to 97, you're doing the work that this has already done for you. So if they give you the significance level, you're going to just use these numbers. There's no need to split it and do all the work. So 5% is the same as 95%. So you have a low, high split, okay? So it's 1.96 or negative 1.96. So these are our rejection regions. If you're going to do it by this, which I would suggest. Now we're going to find our z-score. So our statistic, you're going to have the first mean, which is 3,060 minus the second mean, minus 0. So I'm just going to skip that part. Divided by the square root of the first standard deviation squared over the first sample size, which is 250, plus second standard deviation squared over the second sample size. Now get your calculators out, guys, because you can see there's going to be a lot of little things you're going to miss typing this in. See what you get. Okay, I got 1.85. So at this point, guys, if you're doing the rejection regions, you can just do this. 1.85, is it in the rejection region? No, it's not. So we do not have enough evidence to reject the null hypothesis. Not enough evidence to reject the null. And since the claim was they are different, we are going to reject the claim. The guy said there is a difference between Florida and California's credit card debt. We can't say that there actually is. We don't have enough evidence to support that. Okay? Okay. So the null hypothesis is saying they have the same mean debt. All right? The researcher is claiming that they don't. So this here is the claim. So, say it with me. All right. We're not in the rejection zone. We're in the acceptance zone. So we are accepting, not rejecting the null. I know, it's how it's sorted. I get it. There's not enough evidence to reject the null. Therefore, there's not enough evidence to support the claim. Okay? So it's the same deal from last chapter. We're kind of doing the same thing, just with a different formula. Because we're using two samples and comparing the means on two samples. You're going to try the next one. All by yourselves. See what you do. Ready? And this is the last slide. You do it and you start working your homework. Okay, everybody try. Work on it, work on it, work on it. All right. Guys, if you want to find the p-value, you can do that. We have a two-tailed test. So to find the p-value, you'd have to go to 2.8 on your chart. You would have to find the z-score, which is, or the probability, which is 0.9974. You have to subtract that from 1. So 1 minus 0.9974 gives me 0.0026. And then you got to multiply that by 2 because you have 2 regions. So the p-value, it's much more work. So 2.8 on the chart gives me 0.9974. Then you have to do 1 minus 0.9974. And then you got to 2 minus that, or 2 times that. So you get 0.005, which is lower than our significance level, which is why we reject it. Okay? Regions, a little bit easier on this one, okay? You do the regions. All right? Here, start your math Excel, guys. See if you can do